Tonight, drift gently through the slow-turning arms of our home galaxy, where billions of stars wheel in silence, far above the noise of the world, far beyond the thin shell of our atmosphere. An immense pinwheel of light is turning slowly, patiently across the dark. It has been turning for more than 13 billion years. It will keep turning long after we are gone. And we, every one of us, are riding inside it. So close your eyes and let yourself fall softly into that vast, luminous spiral. Welcome to Let's Learn While You Sleep. Tonight, we are going to wander together through the great spiral arms of the Milky Way, the galaxy we call home. We will move slowly, the way starlight moves, with no urgency at all, and we will look at the soft architecture of our galaxy, its rivers of stars, its quiet dust lanes, its gently glowing nurseries where new suns are being born. You do not need to remember anything. You do not need to follow along. You only need to rest and let the words drift over you like a slow current of light. Picture our galaxy as an enormous wheel of glowing mist, roughly 100,000 light-years from edge to edge, turning so slowly that a single rotation here in our neighborhood takes about 230 million years. And tonight, we will trace its arms, one by one, until sleep finds you. Let us begin with a sense of scale, gently, because the size of our galaxy is one of those quiet truths that takes a long time to settle into the mind. The Milky Way is a barred spiral galaxy, roughly 100,000 light-years across, and about 1,000 light-years thick through most of its disk. A single light-year, remember, is the distance light travels in 1 year, moving at nearly 300,000 kilometers every second. So when we say 100,000 light-years, we are speaking of a distance so vast that even light, the fastest thing in the universe, would need 100,000 years to cross it. And yet, this great wheel of stars is only one of perhaps 2 trillion galaxies in the observable universe. Inside our galaxy, current estimates suggest there are between 100 billion and 400 billion stars threaded together by gravity, drifting in long, graceful curves around a common center. Most of those stars we will never see with the naked eye, even on the clearest night. The faint band of light we call the Milky Way, that soft river arching across a summer sky, is in fact our edge-on view of the galactic disk, the combined glow of countless distant suns blending into a single luminous mist. We are inside that disk, looking outward through its plane. We cannot step back and see our galaxy from above. No spacecraft has ever traveled far enough, and likely none ever will, at least not within any human timescale. Everything we know about its shape, its arms, its structure, has been pieced together patiently from radio waves, from infrared starlight, from the careful mapping of stellar motions across decades. And so the picture we hold of the Milky Way is, in a sense, a portrait drawn from the inside, like trying to sketch the shape of a great cathedral while standing somewhere within one of its halls. Tonight, we will walk those halls together, slowly, and let their proportions settle softly into the quiet of your mind. Now, consider the shape itself, the great pinwheel turning in the dark. The Milky Way is not a simple disk of evenly scattered stars. It has structure, and that structure is what astronomers call spiral arms. Imagine, if you will, a slow, wide whirlpool, a curl of cream poured into dark coffee, the long, lazy turns of a hurricane seen from orbit. Our galaxy carries a similar elegance, though it is built not from water or air, but from stars, gas, and dust. At its very center sits a long bar of older stars, an elongated cluster of warm golden suns crossing the galactic core. From the two ends of that bar, the major spiral arms emerge, sweeping outward in graceful curves and trailing behind the rotation of the galaxy like the arms of a slow dancer. Astronomers currently recognize a small number of major arms and several smaller ones, though the precise count has shifted as our telescopes have sharpened. For decades, 4 major arms were drawn into textbook diagrams. More recent surveys, especially in infrared light, suggest that 2 arms may dominate, with the others being thinner spurs and branches. This is one of those open questions in astronomy, gently being refined as new data arrives, year by year. What is certain is that the arms are not solid objects. They are not fixed bands of stars carrying the same suns around the galaxy forever. Instead, they are something stranger and more beautiful. They are regions where stars and gas pile up briefly as they orbit, like cars slowing through a wide bend in a highway, gathering into a denser, brighter stream before passing through and moving on. The arms are patterns in motion, density waves that move through the disk, glowing more brightly than the spaces between, because that is where the youngest, hottest, most luminous stars are born. So tonight, when we speak of the arms of the Milky Way, picture not solid ribbons, but slow, luminous traffic, ever-changing, ever-glowing, written in light across the dark. Let us drift now toward one of those arms, the one we call the Perseus Arm. It lies outward from the sun, farther from the galactic center than we are, a long, sweeping band of stars and dust that curves through the disk for tens of thousands of light years. On a dark winter night in the northern hemisphere, when you look up toward the constellation of Perseus, your gaze passes through this arm. Some of the bright stars you see in that direction are the luminous beacons of the Perseus Arm itself. Blue, white giants, hot and young by stellar standards, burning fiercely through their short lives. The Perseus Arm is rich in star-forming regions, vast clouds of hydrogen gas illuminated from within by newborn stars. Among them is the double cluster, a pair of dense stellar groupings visible to the naked eye on clear, moonless nights, hanging like 2 faint smudges of light between Perseus and Cassiopeia. Each cluster contains hundreds of young blue stars, only a few million years old, mere infants compared to our sun's nearly 5 billion years. Astronomers estimate the Perseus Arm lies roughly 6,000 light-years beyond us, though its exact distance has been a subject of patient measurement, and even small refinements in that number are quiet milestones in the field. The arm is broad and somewhat irregular, with smaller spurs branching off, including a structure sometimes called the Cygnus spur. Inside the arm, vast molecular clouds drift through the dark, cold and silent, sometimes hundreds of light-years across, holding within them the raw material of future suns. Some of these clouds are slowly collapsing under their own gravity, the first quiet steps in the long process of starbirth. Others have already given rise to bright new stars whose light is now reaching us after journeys of thousands of years through empty space. So, when you look toward Perseus on a winter night, you are not just seeing scattered points of light. You are looking through one of the great spiral arms of our galaxy, a slow river of stars stretching far beyond what any human eye can fully see. And now, gently, let us turn inward, toward the arm that lies between us and the galactic center, the Sagittarius Arm. This is the arm we glimpse most vividly on summer nights in the northern hemisphere, when the constellation of Sagittarius rises low in the south, and the Milky Way pours upward from the horizon in a thick, glowing band. That radiance is no accident. When you look toward Sagittarius, you are looking past our own neighborhood through the Sagittarius Arm and onward toward the dense, golden heart of the galaxy itself. The Sagittarius Arm is closer to the galactic center than we are, lying perhaps 6,000 to 7,000 light-years inward of our position, though the exact geometry is still being refined by ongoing surveys. It is rich with some of the most beloved sights in the night sky. The Lagoon Nebula, a vast cloud of glowing pink gas where new stars are forming, lies along this arm. So does the Trifid Nebula, with its three-petaled dark lanes of dust slicing through luminous gas. So does the Eagle Nebula, home to the famous Pillars of Creation, those towering columns of cool gas and dust where stars are being born even now, sculpted by the radiation of nearby young suns. Each of these nebulae is a stellar nursery, a slow, quiet factory of light where clouds of hydrogen are collapsing into infant stars over millions of years. The Sagittarius Arm carries them like jewels along its length. And beyond the arm, deeper still, lies the central bulge of the galaxy, a swarm of older, redder stars packed densely around the core. At the very heart of it all sits Sagittarius A-star, a supermassive black hole roughly 4 million times the mass of our Sun, around which the inner stars of the galaxy orbit in tight, elegant ellipses. We will return to that mysterious heart on another night. For now, just rest in the knowledge that when you look towards Sagittarius, you are gazing through a luminous, star-forming arm, all the way down toward the galaxy's quiet, brilliant core. Beyond the Sagittarius Arm, deeper still toward the heart of our galaxy, lies the Scutum-Centaurus Arm, considered by many astronomers to be one of the two dominant spiral structures of the Milky Way. It curves through the inner regions of the disk, glowing with the light of countless ancient and newborn suns alike, threading its way around the galactic core in a slow, patient embrace. Recent infrared surveys, peering through the dust that veils so much of our galaxy from ordinary view, suggest that Scutum-Centaurus may be one of only two truly major arms, while others, like Perseus and Sagittarius, may be somewhat less prominent, more like graceful secondary tributaries. And yet, even with all our telescopes, even with the great observatories perched on mountaintops and the satellites adrift above our atmosphere, we cannot see the whole shape from outside. We are within it. We are inside the painting, looking outward at the brushstrokes from a single, quiet position near one edge. Imagine for a moment standing in a vast cathedral so large that its walls vanish into mist, and trying to describe its architecture from a single pew. That is our task as we map the spiral arms. We listen to radio waves emitted by clouds of hydrogen gas. We measure the distances to stars by the slow shift of their positions across years, and from these whispers, we assemble a picture. The Scutum-Centaurus Arm in this picture is rich with stellar nurseries, regions where gas and dust collapse under their own gravity to ignite as new suns. It is a place of beginnings, of clouds slowly tightening into spheres, of light kindling where there was once only cold darkness. Across millions of years, generations of stars have been born along its length, lived their luminous lives and dissolved back into the interstellar medium, seeding the next generation with elements forged in their cores. The arm is, in a sense, both ancient and forever young, a slow river of creation flowing endlessly around the center of our galactic home. And then there is the outer arm, sometimes called the Norma outer arm, which traces the far edge of the spiral pattern, drifting through regions where the disk thins and the stars grow sparser. Out here, the galaxy begins to fade into the surrounding halo, that vast spherical cloud of older stars and dark matter which envelops the entire spiral disk like a soft, invisible mist. The outer arm is quieter, less populated, a frontier where the rhythms of starbirth slow and the spaces between suns grow longer. If you could stand on a planet orbiting a star within this distant arm, the night sky would look strikingly different from our own. The familiar river of light we call the Milky Way, that luminous band arching across our summer skies, would appear thinner, more delicate, perhaps even broken in places, because you would be looking back across the disk from near its outermost reach. Astronomers continue to debate the exact structure of the outer arm, with some studies suggesting it may extend much farther than once believed, possibly wrapping around the galaxy in a long, faint coil of gas and dim stars. Current evidence hints that the Milky Way's full extent may be considerably greater than the visible disk we typically describe, with stars detected at distances of well over 50,000 light-years from the galactic center. Consider that for a moment. A single light-year is already a distance so immense that the swiftest spacecraft humanity has ever built would require tens of thousands of years to traverse it. And here we are, speaking of 50,000 such distances stretched end to end, all contained within the pinwheel of our home galaxy. The outer arm holds the youngest stars on the periphery, scattered like distant lanterns across an enormous, slowly turning sea. It is a place where gravity's pull from the bright center has weakened, where the orbital speeds of stars become a little harder to predict, and where the great mystery of dark matter, that unseen gravitational presence, makes itself most strongly felt in the stately motion of the disk's outer edge. Let us pause now and consider what holds these arms together, what causes the spiral pattern to persist across billions of years rather than dissolving into a featureless blur. For a long time, this was one of the great puzzles of galactic astronomy. If the arms were simply collections of stars locked into place, they would wind tighter and tighter as the galaxy turned, since stars closer to the center orbit faster than those far out. Within only a few rotations, the spiral pattern would coil into invisibility. And yet the arms remain, gracefully traced, persistent across the deep ages of cosmic time. The leading explanation, developed in the mid-20th century by astronomers Chia-Chiao Lin and Frank Xu, is known as density wave theory. According to this idea, the spiral arms are not fixed structures of stars at all, but rather slow-moving waves of higher density that ripple through the galactic disk. Stars and gas clouds drift in and out of these waves as they orbit the center, much as cars drift through a slow-moving traffic jam on a highway. The jam itself moves more slowly than any individual car, and the cars that pile up within it are not the same cars from one moment to the next. In the same way, the bright arms we see are regions where stars and gas have temporarily clustered, where the increased density triggers waves of new star birth, lighting up the structure with the brilliant blue glow of young, massive suns. Other theories, more recent, suggest that the arms may be more dynamic than density wave theory alone implies, perhaps reformed continually by gravitational instabilities and the influence of nearby satellite galaxies tugging at the disk. The truth, as is often the case in science, may involve elements of several explanations woven together. What we can say with confidence is that the spiral pattern is alive in a quiet, slow, moving sense, breathing across hundreds of millions of years, sustained by gravity and motion and the gentle accumulation of matter into glowing crests of stellar light. And we, drifting within it, are part of that long, patient music. Now, let us return for a moment to our own modest position within this grand structure, to the small bridge of stars known as the Orion Spur, sometimes called the local arm. Once thought to be merely a minor offshoot, a kind of stellar bridge between the larger Sagittarius and Perseus Arms, recent observations suggest the Orion Spur may be more substantial than astronomers first believed, perhaps a significant arm in its own right, stretching for thousands of light years through our local region of the galaxy. Our Sun resides within this gentle structure, slowly orbiting the galactic center at a speed of roughly 220 kilometers per second. That is fast beyond comprehension by everyday standards. And yet, because the galaxy is so vast, a single complete orbit, what astronomers sometimes call a galactic year, takes approximately 225 to 250 million years to complete. Consider what that means. The last time our Sun occupied the position in space where it sits tonight, dinosaurs were just beginning their long reign upon the Earth. The continents wore unfamiliar shapes. The atmosphere held different proportions of gases. Entire categories of life that have since arisen and vanished had not yet appeared. And during that single galactic orbit, our small solar system has drifted through different stellar neighborhoods, passed near and far from the dense concentrations of nearby arms, and witnessed in its slow and patient way the great wheel of the Milky Way turning beneath it. The Orion Spur is, by any measure, a quiet stretch of cosmic real estate. It is not crowded with the brightest stellar nurseries. It is not threaded with the densest molecular clouds. It is, in many ways, a peaceful neighborhood, sheltered enough from intense radiation and supernova activity that life on at least one small blue planet has had the long, uninterrupted time required to develop. Somewhere in that thought lies a quiet wonder that our existence is woven into the gentle structure of this particular spiral spur, a small thread within the great spiral tapestry of the Milky Way. Consider for a moment the sheer scale of motion involved in our cosmic neighborhood. Our Sun, carrying the Earth and all the worlds of our solar system in its quiet gravitational embrace, travels around the center of the Milky Way at roughly 220 kilometers per second. That is a speed almost too vast to feel, and yet, even at such velocity, a single orbit around the galactic center takes approximately 225 to 250 million years. Astronomers call this span a galactic year, and it is a humbling unit of time. The last time our Sun occupied this exact position in its orbit, dinosaurs had not yet emerged on Earth. The continents wore different shapes, the oceans held different creatures, and the very air carried a different chemistry. And by the time our Sun completes its next galactic year, what will Earth look like then? We cannot know. We can only orbit and wonder. Within the Orion Spur itself, the Sun drifts among countless companions, though not so closely that any single neighbor dominates our night sky. The nearest star system, Alpha Centauri, lies roughly 437 light-years away, a distance so immense that the light reaching your eyes from it tonight began its journey before many of the events of your own life unfolded. Beyond Alpha Centauri, the stars thin and thicken in subtle patterns, some clustered in young associations born from the same molecular cloud, others ancient travelers passing through. Our sun, too, is a traveler. It was not born where it now resides. Current evidence suggests that the sun formed in a stellar nursery long since dispersed, and over billions of years it has wandered, drifting slowly through different regions of the Orion Spur, encountering perhaps different densities of gas and dust along the way. Somewhere in that long, slow drift, Earth came to be. Somewhere in that drift, life emerged. Somewhere in that drift you came to lie here, listening as the galaxy turns its slow and silent wheel around you, indifferent and beautiful, and entirely unhurried by your small and gentle breathing. Let us drift now toward the very heart of the galaxy, that mysterious and luminous region we call the galactic center. It lies roughly 26,000 light-years from Earth, in the direction of the constellation Sagittarius, and on a clear summer night in the southern sky, when the Milky Way arches overhead, you are looking, in part, toward this glowing core. At its very center sits one of the most enigmatic objects in modern astronomy, a supermassive black hole known as Sagittarius A-star. Its mass is estimated at approximately 4.3 million times the mass of our Sun, compressed into a region so small that by cosmic standards, it is little more than a point. We cannot see Sagittarius A-star directly, of course, because no light escapes a black hole's event horizon. But in 2022, the Event Horizon Telescope collaboration released the first image of its glowing accretion environment, a ring of superheated gas swirling around an unfathomable darkness. Around this central black hole orbits a dense bulge of stars, ancient suns mostly, many of them red and yellow giants, billions of years old. The bulge is roughly spherical, or perhaps more accurately, peanut-shaped, and within it the stars move not in the orderly disk of the spiral arms, but in chaotic, looping orbits, plunging close to the center and swinging far out again, like bees swarming a hive. Closer still to Sagittarius A-star, astronomers have tracked individual stars whose orbits carry them frighteningly near the black hole. One such star, designated S2, completes an orbit every roughly 16 years, and at its closest approach, it whips past the black hole at several percent of the speed of light. Observing these stellar dances has provided some of the strongest confirmations of Einstein's general theory of relativity, as the predicted curvatures of space and time precisely match what we observe. And yet, despite all our measurements, the deepest nature of what lies inside that event horizon remains entirely unknown. We do not yet know what becomes of matter and information once they cross that final boundary. It remains, perhaps fittingly, one of the universe's most patient mysteries. Surrounding the bulge and the disk of the Milky Way, extending far beyond the spiral arms, lies a vast and ghostly region known as the galactic halo. Unlike the bright, busy disk where our solar system resides, the halo is sparse, ancient, and mostly invisible to the unaided eye. It contains a scattered population of very old stars, many of them gathered into globular clusters, dense, spherical swarms of perhaps 100,000 to 1 million stars, bound together by their mutual gravity. These globular clusters are among the oldest objects in the galaxy. Some are estimated to be roughly 12 to 13 billion years old, nearly as old as the universe itself. Astronomers have catalogued approximately 150 globular clusters orbiting the Milky Way, and each one is, in its way, a fossil from the galaxy's deep past. They formed before the disk fully settled into its present spiral shape, and they have witnessed the slow assembly of the Milky Way as smaller galaxies merged and were absorbed across cosmic time. Beyond even these clusters, the halo contains something far stranger and more mysterious. Current evidence strongly suggests that the visible matter of the Milky Way, the stars, the gas, the dust, the planets, accounts for only a small fraction of the galaxy's total mass. The rest, perhaps 85 to 90% of the mass, is composed of what scientists call dark matter, a substance that emits no light, absorbs no light, and reflects no light. We know it exists primarily through its gravitational effects, the way it bends the paths of stars and the way galaxies rotate faster at their edges than visible matter alone could explain. Dark matter forms an enormous, roughly spherical halo around the entire galaxy, extending perhaps several 100,000 light-years outward, and within this invisible cocoon, the visible Milky Way drifts like a luminous fish in a dark and silent sea. What dark matter actually is remains one of the great open questions of physics. Some researchers propose exotic particles never yet detected. Others suggest modifications to gravity itself. The mystery deepens, and the halo holds it. Now, let us turn our slow attention to the gas and dust that fill the spaces between the stars, the medium from which the spiral arms draw their continuing power to create. Astronomers call this the interstellar medium, and although it appears to our eyes as empty blackness, it is in truth a thin and restless ocean of atoms and molecules and microscopic dust grains. In the densest regions, vast clouds of cold molecular hydrogen gather, sometimes spanning hundreds of light-years across, and within these clouds, gravity slowly pulls matter inward, knot by knot, until temperatures and pressures rise to the threshold where new stars ignite. These stellar nurseries are concentrated along the spiral arms, and they are responsible for some of the most beautiful sights in our galaxy. The Orion Nebula, only about 1/344 light-years from Earth, is one such nursery. Within its glowing folds of gas, hundreds of young stars have recently been born, and many more are still forming, hidden behind veils of dust that absorb visible light but glow brightly in the infrared. Other regions, like the Carina Nebula and the Eagle Nebula, contain the famous pillars of creation, those towering columns of gas and dust photographed by the Hubble Space Telescope and later in even greater detail by the James Webb Space Telescope. These pillars are vast, several light-years tall, and they are slowly being eroded by the radiation of nearby massive stars. Within their dense interiors, new stars continue to form, even as the pillars themselves are sculpted away. The cycle is patient and ancient. A massive star is born from a cloud of gas. It lives for only a few million years, burning fiercely. It dies, often in a supernova explosion, and its scattered material, now enriched with heavier elements forged in its core, drifts back into the interstellar medium. There, in time, it becomes part of a new cloud, a new collapse, a new star. Every atom of carbon in your body, Every atom of iron in your blood was once forged inside such a star, somewhere in the long-turning arms of this very galaxy. In these vast clouds of gas and dust, something remarkable is always unfolding, slowly, patiently, across spans of time that dwarf any human reckoning. Stars are being born. Consider for a moment a giant molecular cloud, cold and dark, drifting through one of the spiral arms, perhaps within the Carina or the Sagittarius Arm. These clouds can stretch across hundreds of light years and contain enough material to forge millions of suns. They are among the coldest places in the galaxy, with temperatures hovering only a few degrees above absolute zero, and they are rich in hydrogen, helium, and traces of more complex molecules. For long ages, they simply drift, turning gently, holding their secrets. And yet, something can disturb them. A passing shockwave from a distant supernova, a gravitational tug from a neighboring cloud, the slow squeeze of a spiral arm itself. Any of these can begin the cascade. Pockets within the cloud grow denser. Gravity, that quiet and relentless sculptor, begins to pull the material inward. As the gas falls, it heats. As it heats, it glows. Across hundreds of thousands of years, a protostar takes shape at the heart of a slowly collapsing core, surrounded by a swirling disk of leftover material. And then, when the temperature at the center climbs to roughly 15 million degrees, hydrogen begins to fuse into helium and a new star ignites. Somewhere in that darkness, light begins. The Milky Way, current estimates suggest, gives birth to perhaps 1 to 2 new stars each year, on average, though the rate fluctuates and the figure carries some uncertainty. It is a slow rhythm, a quiet music, a galaxy breathing into existence one luminous spark at a time. Many of these stars are born in clusters, dozens or hundreds together, illuminating the very nebulae that gave them life. The famous pillars within the Eagle Nebula, the glowing folds of the Orion Nebula, the rose-colored regions of Carina, all of these are stellar nurseries, places where the galaxy is, even now, quietly weaving its next generation of suns out of cold and ancient dust. And just as stars are born within the spiral arms, so too do they end their long lives there in ways both gentle and violent. Consider a star much like our sun, perhaps a little larger, glowing patiently for 10 billion years or so. When at last its core has fused most of its hydrogen into helium, the star begins to change. It swells outward into a red giant, its outer layers expanding to many times their original size, cooling as they reach further into space. Eventually, those outer layers drift away entirely, peeling off in soft, luminous shells, forming what astronomers call a planetary nebula, though it has nothing to do with planets. The name is a holdover from early telescopes, when these glowing rings looked faintly like the disks of distant worlds. The exposed core, now a small, dense and intensely hot remnant called a white dwarf, settles into a slow cooling that will last for billions of years. But for the most massive stars, those born with perhaps 8 or more times the mass of our Sun, the ending is altogether more dramatic. When their cores finally run out of fuel, gravity wins suddenly and completely. The core collapses in a fraction of a second, and the outer layers rebound in a titanic explosion known as a supernova. For a brief time, sometimes only a few weeks, a single supernova can outshine an entire galaxy of hundreds of billions of stars. In its blast, the elements forged within the star, carbon, oxygen, silicon, iron, and many others, are scattered back into the interstellar medium, seeding the next generation of clouds, the next generation of stars, the next generation of worlds. And what remains at the center, depending on the original mass, may be a neutron star, a city-sized object so dense that a single teaspoon of its material would weigh roughly 1 billion tons, or, in the most extreme cases, a black hole. Across the spiral arms, this great cycle turns endlessly. Birth and death and rebirth, the slow, patient breathing of the galaxy itself. And so, for tonight, we let the spiral arms slow their turning in your mind. The Milky Way will keep wheeling, patient and unhurried, across the long darkness, just as it has for billions of years. The Perseus Arm, far out beyond us, will keep drifting through its quiet, star-forming clouds. The Sagittarius Arm will keep glowing softly toward the heart of the galaxy. And we, on this small blue world, will keep riding our own gentle current of stars, carried along the inner edge of one slow, luminous curl of light. There is nothing you need to do. There is nowhere you need to go. The galaxy holds you as it has always held you in its slow, immense arms. Let your breathing soften. Let your thoughts dissolve like distant starlight into the dark. And let yourself drift, weightless, into sleep, somewhere among the soft, turning rings of the Milky Way. If you would like to keep drifting through the universe with us, tomorrow night we will travel deeper into our own neighborhood, the Orion Spur, the small, luminous branch where our sun quietly resides. Thank you for spending your night with Let's Learn While You Sleep. Subscribe and come back tomorrow night. We'll be here. Sleep well.